Okay, today we are moving on to Chapter 5, Section 4, Day 1, Understanding Inverse Proportion. And you'll be able to identify inverse proportion and use a table to interpret inverse proportion. So, identify inverse proportion from a table. Some students want to share game cards so that each student gets the same number of cards. The table shows the relationship between the number of students, X, and the number of cards. Each student gets Y. So, as the number of students increases, 1, 2, 3, the number of game cards decreases because you have less and less. Because the total number of game cards remains the same, the number of game cards each student receives decreases as the number of students increases. Because the more people you have, the less cards they're going to get. Okay, in this case, you can say that the number of game cards each student receives is inversely proportional to the number of students. From the table, you can see that the product of X and Y is always a constant value. So, X times Y, 1 times 120 is 120. X times Y, 2 times 60 is 120. X times Y, 3 times 40 is 120. For any two quantities, X, Y, that are in an inverse proportion relationship, their product, X, Y, is a constant value called the constant of proportionality. Okay, inverse proportion is sometimes called inverse variation. You can say that the number of game cards varies inversely with the number of students, or the number of game cards and the number of students are inverse variation. Okay, so let's go on to example 1 here. Tell whether the quantities are in inverse proportion from the table. The table shows the time it takes T hours for N construction workers to pave a road. Tell whether T is inversely proportional to N. If so, find the constant proportionality. So I'm going to go to the next page now because that's where the table is. All right, so this is not a great copy on here. It's somewhat cut off, but on your paper it is good. So it says we have 1 over 36, 2 over 18, and 3 over 12. Okay, so we need to multiply those. Okay, so we're going to have 36 times 1, which is 36, 18 times 2, which is 36, and 12 times 3, which is 36. Okay, they are inversely proportional because as one goes up, the other one goes down. As the number of workers increases, the number of time it takes decreases. But they all, when we multiply, we get 36. Okay, so therefore, the product of N and T is constant, and our constant of proportionality is 36. Okay, now let us move on to B. All right, so the table shows the time taken, Y hours, by X students to put a jigsaw puzzle together. Tell whether Y is inversely proportional to X. If so, find the constant proportionality. So I'm going to stop it, let you work it out, and then we'll go over it together. All right, so 1 times 2 is 2, 2 times 1 is 2, and 3 times 0.4 is 1.2. Okay, so X does increase as Y decreases, but it is not a constant value. We get 2, 2, and 1.2. So this one would be no, they are not inversely proportional because it's not at a constant rate. Okay, so identifying inverse proportions from an equation. All right, when two quantities such as Y and X are inversely proportional, their product is a constant value. You can write the algebraic equation relating Y and X. So X times Y is your constant, or Y equals K divided by X. So to see whether two variables are in a given equation are inversely proportional, you can use algebra to rewrite the equation in one or both of these forms. Okay, so we have 1/2 Y equals 5 over X. So we need to rewrite that with Y alone. So in order to do that, we're going to have to multiply both sides by the... Okay, so we're going to multiply both sides by the reciprocal of 1/2, which is 2. And we're going to get Y equals 10 over X. Y equals 10 over X is in the same form as Y equals KX, which was just given to us right here. So therefore, K, or your constant proportionality, is 10. So we'll talk about this some more in class tomorrow. Have a good night.